like I said, we have this collection interface and the iterable interface. And the iterable interface, you know, requires these methods be implemented in any class that uses it. Um, and this collections interface, which is right here, requires these methods to be implemented in addition to the methods down here. So, and then basically, you get down to like the list interface, for example, um, which is defined here. Um, I'm not sure what methods it has because it doesn't. This thing doesn't say. But this is an example of how you might actually use one of the classes, because this is how you instantiate like the array list or the linked list or the vector or whatever. You see how they're using this. Okay, that is what they're using as a type. The interface, believe it or not. So they're saying, to access it, let's use this as a type. Okay, and then this happens to be like a generic or whatever, I guess, which is equivalent to um, um, a template in C++. But then this would be the name of their, the instance variable, which is a pointer. But then they're assigning, a new array list or linked list or vector or stack to it. But because they're using this as a type, that means any method that is defined either here or up the hierarchy, they can access in this object, this object, this object, or this object. However, because they're using the list, that like filters it out. So if there's any special methods that or this implements, I guess Stack does implement this interface, by the way. I was confused about that in the last video. But at any rate, if they these like I said, these classes can actually have their own methods in addition to what's in these prototypes. If they do, you can't access them because you're just accessing them with the list interface. The same goes to this linked list. It's actually a dual inheritance interface. So, because it's inheriting some of this and some of this. So, using this, you can access this set of methods in the linked list methods, but not this set. You would have to inherit this because, again, this has its own little set of methods too that's part of this linked list. But you don't get that by just referencing it with the you know, with the list interface, because it does act like a filter. Um, but it's a filter, that because it's the same, it's common to every one of these. You can use that same interface set, to basically, you know, work with each and every one of these objects, these classes. So it's a common set of methods. So I mean, they perform different tasks, but they still have the same interface, so they'll work the same. Um, so you actually use the stack, vector, linked list, and array list the same way. But the results are different because they're different classes, so they'll perform different functions. But their interface is the same, so you send them the same kind of data, and you get the same kind of result out of it, the same type, the same data type result. Again, the result itself will be different depending on the class, but but how you interface to it isn't. So they have that in common. But again, each and every one of these probably does have some of its own special methods, and like I said, this linked list, also is part of this list set. So anyway,